Welcome, teacher, to my presentation. My topic is classification of motorbike and car recognition.
This system performs vehicle image classification by motorcycle and car using convolution neural network implement from scratch. Written by its simplified architecture implementation contain the system achieve stable performance and demonstrate the effect of convolution feature e from init by classification.
In part 1, dataset description. The dataset used in this project consists of RGB image belonging to two vehicle category, motorbike and car. The image were collected from publicly available sources and exhibit a wide range of variation in terms of background, complexity, lighting, condition, object scale, and viewing angle. Subdiversity introduction. Related challenge for visual classification.
Part I is image reprocessing before being fed into the model. All image undergo a series of processing steps. First is resizing. All images are resized to a fixed resolution of 64 multiplied 64 pixels. This step ensures consistent input dimension and reduce computational cost. Second one is normalization. Pixels values are normalized to the range 0, 1 by dividing by 255. Normalization improve numerical stability during training and accelerate conversions. And the final is label encoding. Class labels are encoded as numerical value. 0 is bike and 1 is car. Okay, let's move to the part 3 result. As you can see here, I run 12 epoch with different loss and accuracy. The final accuracy is about 0.73%, and this is the classification report table. Let's move to the chart, line chart. The training and validation loss curve decreased steadily over epoch, demonstrating stable learning behavior and effective optimization. Meanwhile, both training and validation accuracy increased consistently and remain closely aligned throughout training, indicating good generation performance and no evidence overfitting despite the simplified CNN architecture. The confusion metric, the chaotic metric found a fairly good model for classifying model cycle by with 231 correct prediction. However, it still confused 100 105 motorcycles with cars. For cars, the model matched correctly with 167 correct predictions and only 37 motorcycle was mistaken. This is the RC curve chart. The RC curve is significantly higher than the random prediction curve, indicating that the model has good discriminatory ability between the two classes. The accuracy value of 0.85 demonstrates fairly high classification performance with the model providing reliable prediction that far exceeds the level of randomness. Okay. For more information, and please navigate to the system code link for a clearly understanding. And that is the end of my presentation here. Okay, this is the code link that I mentioned before. First, we need to import the file here. We can change the image size to training faster. The data loading, I use TensorFlow, and then I convert to NumPy in order to build the CNN from scratch. The class convolution 2D, mark pooling, and dense. And I evaluation the simple CNN model with untrained CNN about 0.61. This is the non data in here. This is exactly the data trainer epoch 1 to epoch 2012, and this training take a lot of time, about over 2 hours, and I get the final accuracy about 0.73. Here the classification report that I mentioned in the presentation. Okay, as you can see here, the model predict almost exactly what I need. We got a only three prediction is wrong. Okay, this is the chart that I mentioned before.